Hey, this is Joost Impink. I'm going to show you Grocket, the data processing engine, running a query, a join of a dataset with SEC 8K filings and dynamics trading data. So the data engine has a web interface. Right now you're seeing the editor. Obviously, this is where you edit the queries. The second tab is the monitoring tab. Right now nothing is running, so there's not much to see here. And the last tab is where you can see the results. Let me run this query. It's going to take a while. So there you go. The first 7 seconds or so are used to compile the query. So the query is written in R and gets translated into C++ code. And so it takes a little while before it starts running, and there it goes. So the monitoring is quite extensive, especially when you compare it to other processing engines that basically tell nothing other than that, you know, something's happening. Here you have a bit more detail, or a lot more detail. So the disk reading speed here shows 1.5, 2.5, 3 gigabytes per second. So that's how fast the data comes from the disk. And the CPU's utilization is shown here. And the other gauges are more for developers. For example, if you have a memory lock, you know, if you link a library that has that doesn't parallelize well, then this will show trouble. There's also a progress indicator, how much of the data has been read. Since the query is on a couple of years, this query has made a big jump, so this will slowly go to 100% and then the query will be done. So let's go to the editor. I've loaded a data set with 8K filings, so that's material event filings with the SEC. For those filings we have 4 variables: the ticker symbol, the time, the timestamp, that's the date and seconds, and a year and an ID. And we're gonna match that with the dynamics trades. We loaded these variables, so ticker symbol, the timestamp in the day, the date, exchanges that we're not using in this query, the price of the trade, the number of shares traded, and some extra variables that we're not using in this query. So this is written in R, and R executes back in C++. So we use R as the front end, and we translate whatever you see here and into C++ code, which is obviously very fast. So library GTNanix means that we're loading a lot of definitions and functions on variables that put a lot of the complexity in the back end instead of the front end. 2 constants here. I'm interested in a 2-hour return following each 8K filing, and before and after are the variables to set the window. So I want to start measuring right at the event, and I want to end 2 hours later. Load is the function to load the data into a variable or a structure. So I'm loading the SEC filings into the variable events. Likewise, I'm loading the trade data into trades, and I have a filter here. I just want equities, and I want 3 years of data, so the query is reasonably fast. The data engine is smart, so the data is column stored, so it will only load or actually read the variables that are used from the disk. So variables that are not used are not read. Nanex trades has separate variables for date and millisecond of the day, and the SEC filing dataset has a timestamp. So I create a date and a seconds variable based on the time, the timestamp, and push that back onto the events dataset. So then I can join. So this will join the trades with events based on the symbol and date. And this will give 3 years of trading data for each event. So the next step is to filter, because I just want 2 hours, right? So I'm computing the difference between the seconds of my event and the seconds of the trades. So that difference needs to be between the before and after. So now trades will hold all the trades for all my events in the 2-hour windows. And then I need to aggregate these because I want the information for each event. So I group that trade information based on the identifier and the timestamp. So this will uniquely identify each filing. Then I want to know how many trades happened, how much shares were traded, and I want to know the last price of the window and the first price of the window, because then I can construct a return. I saw the notification there popping up, so the query took about almost 6 minutes. View will push back the results into the web interface, but it only will push the first 200,000 results, not to blow up the browser. So that's helpful for testing. And then when the query is good, you can push it to disk and then process it further. In this case, I'm processing it in SAS. So yeah, the query is finished. So the gauges are like all at 0. Let me show you that this tab also shows the C++ code that gets generated. This is more for the developers, so they can see if the code generated is good. So this is the C++ code that actually runs. It's kind of unfriendly for front-end users, but for developers it's very helpful to see what code actually runs. And the visualization tab. So now it's bringing in the data. So there were only 119,000 8K filings in those 3 years. So those are now in the browser memory. So this manipulation happens in the browser. We can see or check if it's indeed the right time frame. So it's 2011 through 2013. That is correct. And let's take a look at some of the larger ones. So I'm sorting down on the number of trades. So this identifier is not a ticker symbol, but okay, so it identifies the 8K file name actually. So we can't really tell from this data which firm it was, but we see the timestamp 11:30 on December 20. That 8K, the following 2 hours were, busy, 190,000 trades. The timestamp here is in milliseconds and not like a friendly, easy to read time. But this first time will be obviously very close to 11:29. And we can see the first trade in that window and the last trade prices. So I derived the stock return from the first and last price. Yeah, this tab also allows you to create dashboards, different kinds of charts and 3D stuff. In this case, the data is not very suitable for that sort of charts, but for more group by kind of stuff, that would be more yeah, appropriate. So in short, we have the editor, very manageable code, like a join on such large data with just basically a handful of lines, about 10-12 lines of code. The monitoring tab to see how it executes and to have some idea of the quality of the code, and some visualization to inspect the results. Alright, well, thanks for watching and have a good day.